Methane gas reacts with chlorine gas to form dichloromethane and hydrogen chloride, as represented by the equation above. CH4 plus 2Cl2 yields 1 CH2Cl2 plus 2 HCl. A 25.0 gram sample of methane gas is placed in a reaction vessel containing 25.8 moles of chlorine gas. The question asks to identify the limiting reactant when the methane and chlorine gases are combined, and next to calculate the total number of moles of CH2Cl2 in the container after the limiting reactant has been totally consumed. First, I converted 25 grams of CH4 into moles of chlorine gas. I divided by the molar mass of 16.04 grams and then multiplied by the molar ratio of 2 moles of chlorine gas to 1 mole of CH4, and got 3.11 moles of chlorine gas. We are given that there are 2.58 moles of chlorine gas. So chlorine is the limiting reactant, because once you convert 25 grams of CH4 to moles of Cl2, you get 3.11, which is more than 2.58. So chlorine is the limiting reactant because it runs out first. Next, we calculate the total number of moles of CH2Cl2 in the container after the limiting reactant chlorine has been totally consumed. All we need to do is a stoichiometry problem converting 2.58 moles of chlorine into moles of CH2Cl2. We divide by the molar ratio of 2 moles of chlorine to 1 mole of CH2Cl2 and find 1.29 moles of CH2Cl2. Question number 2. Iron reacts with oxygen to produce iron 3 oxide as represented by the equation above. 2 iron plus 3 oxygen yields 1 Fe2O3. A 75 gram sample of iron is mixed with 11.5 liters of oxygen gas at 2.66 atm and 298 Kelvin. Part A asks to calculate the number of moles of iron and oxygen before the reaction begins. To solve for moles of iron, I use a simple stoichiometry problem, dividing 75 grams of iron by its molar mass of 55.85 grams, and got 1.34 moles of iron. Since we are not given any mass for oxygen, I use the equation PV equals nRT to solve for n moles. I plug in 2.66 atmospheres for pressure, 11.5 liters for volume, 298 Kelvin for temperature, and R is a gas constant of 0.0821. I solve for N and find that there is 1.25 moles of oxygen gas. Part B asks to identify the limiting reactant when the mixture is heated to produce Fe2O3. To solve this, I use limiting reactant stoichiometry. First, I converted 1.34 moles of iron into grams of Fe2O3. I divided by the molar ratio of 1 mole of Fe2O3 to 1 mole of iron, and then multiplied by the molar mass of Fe2O3, which is 159.69 grams per mole. 1.34 moles of iron produced 106.9 grams of Fe2O3. Next, I converted 1.25 moles of oxygen gas into grams of Fe2O3. I divide by the molar ratio of 1 mole of Fe2O3 to 3 moles of oxygen, and then multiplied by the molar mass of Fe2O3. 1.25 moles of oxygen produces 66.5 grams of Fe2O3. O2 is the limiting reactant since it produces less grams of Fe2O3. The last part of question 2 asks to calculate the number of moles of Fe2O3 produced when the reaction proceeds to completion. I took 66.5 grams since it is a product of the reactant O2. Then I divided by 159.69 grams, the molar ratio Fe2O3, and got 0.42 moles of Fe2O3.